Hello, we are Group R of the Mechanical Design 1 class for the spring of 2015 with Dr. Tuzunoglu. Our team consists of Juan Cuervo, Santiago Almario, and myself, Miguel Rodriguez. Today, we're going to be presenting about the ocean wave energy. In this presentation, we will be going over what is ocean energy, how it is formed, why it is important, the benefits of this renewable energy, the historical background, current and future designs, and we will finish with the conclusion. So what is ocean wave energy? It's a renewable energy whereby the energy that is being generated naturally by wave is captured. So how does it work? As the wind blows over the ocean, ripples are produced that eventually turn into swells. The swells can travel far distance without losing much energy and have a density higher than the wind or solar power. So why is important? Electricity is expected to double within the next 20 years due to worldwide demand and the ever-increasing population. There is a challenge ahead of us to make this increasing global demand for energy consumption. The vast ocean of our world have tremendous amount of energy and power that have not been tapped, which has the potential to provide a lot of renewable energy. Some of the benefits that is the renewable, environmental friendly, and has no damage to the land. Now, I just want to touch a little about this topic to let the audience know what is going on, which is the literature or survey. When initiating the studies in ocean wave energy and searching for reference, there was a clear lack of suitable textbooks which bring together the approach of wave theory, the modeling techniques of these renewable sources, and the several current and future technological developments of this source. Several conference proceedings has been a good starting point over the past decades. The European Wave and Tidal Energy Conference, which takes place every other year, is the most relevant example of an early conference that was held in Sweden in 1979. These conferences are a demonstration of continuous interest in ocean wave energy in both the industrial and scientific communities. Conferences like this has been the primary source of information for this topic. Before talking about the current and future designs of the ocean wave energy mechanisms, Santiago will be talking about the background history of ocean wave energy.
Ocean wave energy has not had an extensive history, but can be traced to its first patent, which was filed in 1799 in Paris, France by a fellow named Girard. This was the first account that was used waves from the ocean for energy. Even though the 19th century had a lot of first technologies being developed, it was not until the 1970s which allowed for the expansion and growth of the technology. This was mainly due to the fact that there was an oil crisis which allowed for the attraction to alternative energy sources more desirable. It is extremely important to note that a great contribution was made during this oil crisis by Professor Stephen Salter from the University of Edinburgh. His design of a floating mechanism which is highly efficient in absorbing waves allowed for the interest in ocean wave energy to spur during this time, as he published his work in a very respectable journal called Nature. When the 1980s came around, oil prices came down from their highs in the 1970s, which allowed the technology of water wave energy to be once again seen as uneconomical. This thought process was then reversed once again as the oil prices started rising in the 1990s, and a greater concern was placed on the environment and reduction of carbon dioxide emissions. In the 1990s, great strides were made in the development of these technologies, where two of the main governments which have been providing funding for research in this area are the United Kingdom and Portugal. As the case was with the wind energy, the technologies are still being developed and modified, and there is not one model which is dominant over others. Some of the current designs which are being implemented specifically in a large scale, are outlined in the current design section. Up next, Juan will be speaking about the current and future technologies for ocean wave energy.
Among the current designs in the wave energy field is the Archimedes wave swing. This design is one of the few concepts fully developed that is totally submerged in the ocean, which is really important since it is not visible, the public acceptance is not as problematic. The design consists of an air-filled cylinder that is fixed to the seabed and open at the top. The bottom cylinder, or silo, is then closed by another cylinder called the floater. An airlock is developed between the both cylinders, and so water can flood the silo. The floater can move up and down due to increased or released pressure, which is associated with the incoming wave crest directly above the device. The oscillation produced in the system by the waves can be converted into electrical power by the use of a power takeoff system. The Archimedes wave swing uses a permanent magnet linear generated as its power takeoff system. Another design being currently implemented is the oscillating water column. This system is formed by a chamber which is filled with air above the water line. Driven by wave action, the water level inside the chamber rises and falls, pressurizing the air within the chamber. As the water level inside the chamber rises, pressurized air escapes from the chamber through a turbine generator that produces electrical power. When the water line goes back, air is drawn again into the chamber in order to continue the power production process. In addition, the turbine generator unit has the capability of self-rectification, so that the direction of the turbine rotation remains constant throughout the power cycle. Another current design is the Wave Dragon. The Wave Dragon project is the result of cooperation between 6 different European partners: Denmark, United Kingdom, Ireland, Sweden, Austria, and Germany. The Wave Dragon is based on a very simple principle out of catching energy from waves. When the waves hit the wave deflectors, they climb and ramp and fall into the tank where the water is stored. The water stored in the tank then flows out of the turbines, thus creating electricity by the use of an electrical generator. At full scale, the Wave Dragon has the potential of generating up to 7 megawatts. That is enough electricity to power up 10,000 homes. Having an array of units connected together, the project aims at producing 80 to 100 megawatts. Among the possible future developments, there is a new technology known as the wave carpet. The theoretical and applied fluid dynamics laboratory at UC Berkeley is developing a new technology for wave energy conversion. This idea comes from the fact that muddy sea floor can take out huge amounts of energy from ocean waves. The action of the waves cause the muddy sea floor to move up and down. By designing a carpet that acts as the muddy sea floor, energy can be extracted out of the waves by using double-acting hydraulic cylinders underneath the wave carpet. Therefore, in both motions, up and down, hydraulic pressure is generated and sent to a discharge pipe, bringing hydraulic pressure on shore, where it can be converted into electricity by the use of a turbine generator. Next, Santiago will talk about the discussion and conclusion.
Discussion and conclusion. Mitigating climate change has to be combined efforts by technologies that are already developed and are still being developed. At the current moment, ocean wave energy is at its beginning stages, such as how wind energy was a couple of decades ago. When incentives were given by governments to develop this technology, the wind energy technology was developed, which allowed for one overall design model to be standard for most wind energy systems. Likewise, at the current moment, ocean wave energy does not have one overarching design which dictates most of the technologies. This is due to the fact that ocean wave energy is a relatively new energy source being developed, but it also has to do with the fact that energy can be obtained through this source by a wide range of models. Overall, once more funding is allocated for the technology, there will be better ways to develop it to produce in larger scales to have it become a substantial renewable source of energy. Renewable energies are in high demand to prevent further damage of our environment, which is why ocean wave energy is a very viable resource. These technologies clearly allows for a long-term solution which can generate a lot of energy for the long run. At the current moment, there are not many full-scale models, but those which have been implemented and are working have proven that these technologies do have a future and do have the capabilities to supply large amounts of energy. Thank you.